Okay, so I will qualify this by saying I am a chemical engineer, which usually in the field means we know like absolutely nothing. That's kind of our starting point. We're really good at making a lot of educated guesses. So I'll give you a little bit of perspective on how I got into nanotechnology, where I think the importance of nanotechnology can be in medicine, and why it even became a factor in medicine in the first place. So nanotechnology sort of came on the radar of medicine in around the 1970s. The main reason, I think Rohan touched upon this a little bit, and I'll try and broaden it and expand upon it, is because there was a large delivery challenge in medicine. So if you think about cancer, you're giving a cocktail of chemotherapeutic drugs to try and treat a patient. There is nothing about that drug that is going to tell it to go specifically to the cancer. So there was no way to say that when we put a drug into the body that it's going to go where we need it to get to. And there were a lot of good drugs out there. They worked exceptionally well in preclinical studies and in vitro cell culture type studies and animal models. But when you put them into humans, they didn't have the ability to get to where they needed to go. So in engineering, it's a great opportunity. You come in, you look at something, you have a technical problem. It's largely a delivery problem. Can we potentially come in and play a role and design a platform that might allow us to get something to the site of interest where we need it to actually get to, and by default, not get it everywhere else? So there were a couple particle platforms, and Rohan mentioned a few. He mentioned the Prussian blue particle platform that he's working on. There's been about 13 other particle platforms that have actually made it into commercial use. None of those up until this time have actually been part of standard of care. Those particle platforms, some of you might have heard of. They're things like Abraxane, which is a Taxol-loaded polymer system. Polymers are just long repeating units of carbon, nitrogen, oxygen. They can often be broken down in the body or cleared out from the body. There was also particle systems like liposomes. So Doxil was another example, which is a doxorubicin-loaded liposome. Liposomes are sort of these spherical particles. They're made up of fatty acids, the same thing that your cell membranes in your body are made up of. So they're nice because they basically are made of the same components of what's already in your body. So they're very compatible. Now, these particle platforms were all used mostly in cancer applications. And unfortunately, as many of you know, cancer is a very low-hanging fruit application for new technologies because there's just not much out there that works very well. So for new, and especially novel drug delivery technologies, nanotechnology was an exceptional way, cancer was an exceptional way for nanotechnology to kind of come into the field of medicine. So most of these particle platforms initially were for things like pancreatic cancer, prostate cancer, metastatic breast cancer, and they've been used clinically since about 1990. But again, not part of the traditional standard of care. This is the first thing we go to when we're thinking of treating patients.